here's our beta cell. Here's our GLUT2. Here comes our glucose, all right? So in goes the glucose. Glucose gets converted to, so once it comes in, gets converted to glucose 6-phosphate using a high Km, which means it's not very specific, right? Like it's not a great fit between this enzyme and its substrate, which means that you need a lot of glucose for this reaction to happen such that that is half saturated, okay? The reason that you want a high Km here, not that there's a reason, there's no determinism, but the reason that a high Km hexokinase has evolved here is because you don't want it to be so sensitive that without a lot of glucose, you're running this reaction, because then you'll release insulin into the bloodstream and you'll take too much glucose out of the bloodstream, and then things that really need it won't happen. So you don't want this part of the reaction to run unless there's a lot of glucose coming in. Does that make sense? That's why this enzyme is not very sensitive, okay? And we'll say hexokinase because you have gone in there. All right, so then you've got a glucose 6-phosphate. That's our first step, right? And then I just shorthanded that all the way down the chain to oxidative phosphorylation. So all the steps in the middle are happening, okay? Okay, so let's do 1. Glucose goes into the cell. 2. Glucose goes to glucose 6-phosphate. 3. Glucose 6-phosphate runs all the way down to oxidative phosphorylation, right? Okay, let's see which steps so let's go to 4 where we've got a change in the, so ATP increases and ADP decreases. If we think back to our adenosine triphosphate versus our adenosine diphosphate, the ADP is missing one phosphate, and so we're storing energy. We've made a lot of energy here. We're storing it by adding additional phosphates onto our adenosine backbone. Is this started familiar from biochem? Okay, good. Okay, so once that happens, it basically changes certain things inside the cell, and that's what my summary is. Okay, so we've lowered certain intracellular changes, all right? It doesn't really matter what they are for us because we could go on for an hour. Like you could do a whole quarter on just chapter 12. So we're just summarizing here. Okay, you've made certain intracellular changes in the cell such that, so 5, these changes happen, and then 6, the insulin vesicles are triggered to be released. Okay? That is an example of cell signaling. In this case, the glucose served as a signal to the beta cells. It's also using the glucose, right? It's storing ATP so that it can do its job. But as it stores ATP, this is signaling the cell to do something else, because the cell is not only self-sufficient, it works in a network. It has a job, just like every other cell. So as it stores the glucose for its own use, so it can make more insulin, it also recognizes via the changes in relative energy storage that, oh, it's not just me that has this problem. Somebody else probably needs, like I'm storing a lot of energy, I need to release insulin so the other cells can do this too. Question?
For step 2, it says hexokinase, over there it says glucokinase.
Oh, okay, yeah, so a hexokinase is a less specific version of a glucokinase. A glucokinase is a glucose, and we're using glucose here, but a hexokinase means any hexose sugar. So I can change this if that's better. Here, I'll put this up here. Okay, since we're using glucose. Is that better?
Thank you.
Okay. All right, so I'll take a picture of this. Okay. And then when we talk about gene regulation, I don't care that